P must be here, and we know FE. FE is 80. Well, that's nice because that means we know X. So if it wants DE, that's just 2 times 80, which is 160. And DF is just 80 times the square root of 3. Because we knew X. Very simple. Okay, number 18, a flagpole on level ground. Here it is. There's your pole, there's your flag. There's your flag. Casts a shadow 18 meters long. So the shadow is 18 meters long when the sun is 26 degrees up from the horizon. So 26 degrees. How tall is the flagpole? So we want to know its length to the nearest tenth of a meter. Since I look at my angle reference, we're going to say that's the right angle. This is the opposite, and this is the adjacent. So we've got a tangent here. Tan of 26 degrees equals x over 18. In order to get x all alone, we multiply by 18. And we do 18 times the tan of 26 times tan 26, which is a length of about 8.8 meters for our flagpole. All right, last page for Unit 11, I believe, all other than filling in the unit circle. Oh, that's exciting. Okay, how far up a wall can a 14-foot ladder? Well, let's make a wall. Here's our building. Yes, it's a prison. Always is. Don't know why. Never spent any time in prison. 14-foot ladder makes a 76-degree angle with the ground. How far up? So once again, we've got x there. So from my angle of reference, I've got an opposite, and this is a hypotenuse. If you know your SOHCAHTOA, opposite hypotenuse is sine. Sine of 76 equals x over 14. In order to get x all alone, I just multiply both sides by 14. So 14 times the sine of 76, x equals, it goes 13.6 feet up the building. This one, xy is 12 and yz is 7. We want the angle measure of x. Well, if I want this angle, I know it's opposite and I know it's adjacent. So to find angle x to the nearest degree, opposite and adjacent, I'm going to use tangent. Tangent of theta, I'm going to make this theta, it's your angle measure, equals opposite over adjacent, 12 over 7. In order to get tangent alone, I do second tan, inverse tan of 7 over 12, which is 30 degrees. So A is 30 degrees. To find the tangent of z, notice how it doesn't want angle z, it just wants the tangent of z. So from z, tangent is opposite over adjacent, so you would just answer 12 over 7 and give it as a ratio or as a fraction. That's the answer. Okay, triangle TUS. If you're given one like this, just draw a generic triangle, TUS, and label it. TS is 15. Angle S is 60 degrees. Angle U is 40 degrees. Find TU. I want this. Now if you notice, this goes angle, angle, side. If it's not SAS or SSS, it must be a law of sines. So I'm going to say sine of 60 degrees over x, the side across from it, equals sine of 40 degrees over 15, the side across from it. Once again, a little cross multiplication. Sine of 60 times 15 divided by sine of 40. And I get x equals 20.2. Next one, triangle HUG. HU is 25, angle U is 95 degrees, and GH is 40, and we want angle G. Once again, I've got a SSA, so this is the law of sines again. So I'm going to say, hey, sine of angle G over the side across from it equals the sine of 95 degrees over the side across from it. And now we cross multiply, only it's a little bit more work. Here I'm going to do 25 times the sine of 95. Okay, and I'm going to divide that by 40. bearing in mind that now I've solved for sine of g. Sine of g equals 0.62226216863, roundings for chumps. So, if sine of g equals that, I have to take the inverse sine of that to get g all alone. And I find that g equals 38.5. So angle G equals 38.5 degrees. And that is your answer for number 22. Number 23, now I've got a triangle EFD. ED is 9. Angle D is 43 degrees. DF is 10. Notice this goes SAS, which tells me, hey, law of cosines time. And we want this. So, law of cosines, x squared equals 9 squared plus 10 squared minus 2 times 9 times 10 times the cosine of 43 degrees. Look back at your law of cosines. Sorry, I'm way crooked here for that equation, but this is how it's set up. The nice thing about this equation when you're solving for the side is that you can plug it in your calculator all at once. I want x, so I'm going to take the square root of 9 squared plus 10 squared minus 2 times 9 times 10 times the cosine of 43 degrees. And I find x to equal 7.0, basically. Okay? That's how that is done. My last one on here before the unit circle. Ugh. T, R, S. Notice that you can just lay out any generic triangle for these. It doesn't matter. You just make a triangle and mark it so you can see if it's SAS or SSS or whatever it may be. TR is 21. TS is 15. And angle S is 95 degrees. And we want the length of RS. Now what we have goes SSA. So this tells me that it must be a law of sines problem. Okay? The only problem with this problem, let me make sure I mark this right. TS is 15. S is 95. Well, I'm going to change this actually. I'm going to change this problem around a little bit because as it is stated, it is not, it's not going to be solvable. If we use law of sines, we don't know this angle. We would need this to find angle x, and I can't find it. So I'm going to change this just a little bit. I'm going to change this angle to be 95 degrees and say angle T is 95. Okay. Now we can use law of cosines again to solve for x. So x squared equals, see that's what happens when you record this bad boy live. X squared equals my side squared plus my other side squared minus 2 times my side times the cosine of the angle between the sides, which would be 95 degrees. I'm going to want to square root that, so just like before, I can plug this in my calculator all at once as the square root of 21 squared plus 15 squared minus 2 times 21 times 15 times the cosine of 95 degrees. And I get x equals 26.8 to be my length of the missing side. Okay, last thing. The unit circle. Gotta know your unit circle, not too difficult. Let's do degrees first. Here we go. 0, and you've got to go 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and once again you get to 360. Following that 30, then 15 more, then 15 more, then 30 more rule, and then just going around again. That's your rule for degrees. For radians, I always say mark the middle ones the odd fourths, odd numbers over 4. So this one's 1 over 4, which becomes pi goes on top, so that's pi over 4. Come to the next middle. That's the next odd number is 3, so 3 pi over 4. Next middle, way down here. Next odd number is 5. 5 pi over 4. Next middle, next odd number is 7. 7 pi over 4. So those are your odd fourths. The odd numbers 1, 3, 5, and 7 over 4. Okay? Everything else on this unit circle in radians is a sixth. So I start off with 0 radians, and then I'm going to do 1/6, which is pi over 6. You always put pi on the top. Up here you've got 2/6, but 2 over 6 is the same as 1 over 3, so pi over 3. 3/6. 3 over 6 is 1/2, so this is pi over 2. 4/6. 4 over 6 is 2 over 3, so 2 pi over 3. 5/6, you can't simplify, so just 5 over 6. 6/6 is 1, so it's just pi. This is 7/6, so 7 pi over 6. 8/6, 8 over 6 is 4 over 3, so 4 pi over 3. 9/6, 9 over 6 is 3 over 2, so 3 pi over 2. 10/6, cut them both in half, you get 5 over 3, 5 pi over 3. 11/6, just 11 pi over 6. And finally, 12 over 6 is 2, so 2 pi. That's your radians. Watch it again if you didn't get that. All right, I'm going to do the corners first. This is over 1, up 0. Over 0, up 1. Over -1, up 0. And over 0, down 1. So I've got my corners filled in. From there, I always say go 3, 2, 1, 1, 2, 3. Everything goes over 2. And then you square root the top of everything. But if you square root 1, you just get 1, so there's no point. So the square root goes on top of everything that's not a 1. Once you have that quadrant filled out, I just go straight across. Although now I have a negative x because I'm left, so this is negative square root of 3 over 2, comma 1/2. The same values, only I've just switched to the negative. Come straight down. Square root of 3 over 2 goes in the x just like before. 1/2 goes in the y, only now they're both negative because you're left and you're down. And then come straight across, and now this is going to be square root of 3 over 2, 1/2, only a negative y because I'm down, but I'm right. Okay, so I have a positive x. So notice how those 4 points all have square root of 3 over 2, comma 1/2. All right, straight across, straight down, straight over, and straight back up. The middle in each one is always square root of 2 over 2 and square root of 2 over 2, so those are easy to remember. I'm left, so the x is negative. Here, they're both negative because I'm left and I'm down. Here, I have a positive x because I'm right, but I'm down, so I have a negative y. And finally, the other ones all have a 1/2 in the x and a square root of 3 over 2 in the y. So now I've got a negative 1/2 because I'm left, comma square root of 3 over 2, positive because I'm up still. Here, they're both negative. And finally over here I have a positive x but a negative y because I'm down. And that's the unit circle in all its glory. And that's the end of the Unit 11 review. A half an hour later. Hope you enjoyed.